chemistry. We're looking at ideal gas law, but the problem with the ideal gas law, the reason why, because it's ideal, it doesn't deal with all the interaction forces we talked about before, the attraction forces of gravity and electromagnetics. It doesn't deal with elasticity. So we have to change it up a little bit. And the way that we change it up is called a van der Waal equation. It is a relationship of gases in real world conditions, where the pressure is equal to N, the number of moles, times R constant times T, all over V minus N times the constant times B minus N squared, A constant, all over V squared. Now we use that, and these are the values that we'll use. It is in your book, and I'll include it into the note set here. These are values of A and B for various gases in terms of the different values. So let's look at the problem. Calculate the pressure of 36.22 liters of oxygen at 21.72 degrees Celsius if there are 47.223 grams of the gas. Compare the results of the gas expressed in the ideal gas expression. The same problem. All right, so we start with the van der Waal equation. We'll put our values in. Before we do that, though, we need to understand the moles of gas. We have 47.2235 grams of oxygen. 1 mole of oxygen is 32 grams of oxygen, which gives 1.47573 moles of oxygen. So put those values in. Oh, and forget the R when you use 0.0821, because remember, all the constants we have were in atmosphere. So always use 0.0821. So put those in. P is equal to 1.47573 moles times 0.0821 liters atmospheres per mole Kelvin times 294.72 Kelvin, all over V 36.22 liters, 1.47573 moles, that's the N value, and B from that chart was 0.0318 liters per mole, minus 1.47573 moles squared times the A value from the chart, which is 1.36 liters squared atmospheres per mole squared, all over 36.223 liters. When we do that, we get an answer of 98.479 atmospheres. Now, if we compare that with the ideal gas equation, P equals nRT over V, put our values in, we get a value of 0.98577 atmospheres. You see they're relatively close, but there is a slight, and those are due to the attractive forces, and the other values of the kinetic theory basically ignores. All right, so we'll do this one in class. Find the pressure of 40.22 liters nitrogen at 35.7 degrees Celsius if there are 3.115 moles of gas. Compare the results. The ideal gas expression, that's the same problem. And we'll do this one with a partner in class. Determine the pressure of 35.156 liters of argon at 51.07 degrees Celsius if there are 33.215 grams of gas. Compare the results. Okay, that's it. We're done. Take care. Be good.